to graph a quadratic function with leading coefficient 1 or -1. So that means the first term would be just x squared, or the first term might be minus x squared. But there's no number other than 1 multiplied by that x squared. We can know that it's going to have the same shape. So knowing what the graph of y equals x squared looks like is helpful here. And we can just redraw that graph repositioned somewhere else in the plane. So the idea is we need to first find the vertex. The vertex is always the first step in graphing a quadratic function. Next, we determine whether the parabola opens up or down, and that is determined by the leading coefficient. If the leading coefficient is positive, the parabola opens up. If the leading coefficient is negative, the parabola opens down. Then we use this 1, 2, 3, 1, 4, 9 pattern to fill in one side. Here's what that means. On the graph of y equals x squared, it has vertex at the origin, and then it passes through these 3 points. These are easy to remember because it's just 1, 2, 3 for the x values, and then it's the first 3 perfect squares for the y values. Right? 1 squared is 1, 2 squared is 4, 3 squared is 9. So we can remember these values easily and use them to draw a parabola that is repositioned anywhere in the plane. The way we do that is we say, okay, I'm going to start at my vertex wherever that turns out to be, and then I'm going to plot these 3 points relative to the vertex instead of relative to the origin. So almost pretending that my vertex is the new origin. From this 1 here, I'm going to plot the point 1, 1 relative to that vertex. And because in this case the diagram shows a parabola that opens down, I'm going to choose to go down instead of up when I plot that point. Next, I plot the point 2, 4, starting over again at the vertex, going over 2 in the x direction and down 4 in the y direction. It's like plotting the point 2, 4, or 2, -4 in this case, but plotting it relative to the vertex instead of relative to the origin. I then start over at the vertex again, just like we go back to the origin again each time we plot a point, and from there I plot the point 3, -9. Once I've got these 3 points drawn, I can use symmetry to get the other side, because this line, this vertical line passing through the vertex, is also a line of symmetry. So if I come up to the first point that I plotted, this 1, 1, I can now reflect it about that line of symmetry. And then I come back to this second point I plotted, the 2, 4, and reflect it about that line of symmetry. And do the same for my 3, 9. Once I have these points plotted accurately, I'm ready to go ahead and draw the parabola that passes through them. So let's go ahead and follow this process with the function f of x equals minus x squared plus 6x minus 8. The first step is to find the vertex. I can't do anything until I have that vertex identified. So since this is in general form, I'm going to use the vertex formula. H equals minus b over 2a. That's going to be my x-coordinate of the vertex. And then I will plug that result into the function to get the y-coordinate. In this case, my a is -1, the coefficient of x squared. My b is +6, and c is -8. So plugging into this formula, I get minus 6 over 2 times -1, which turns out to be a +3. Be careful about those signs. We have 2 negatives here, and everything is multiplied and divided, so I can go ahead and just go straight to that answer of 3. For k, I'm going to take f of 3, meaning I'm going to plug 3 in for the input variable to the function. This becomes minus 3 squared plus 6 times 3 minus 8, which is negative 9. Note that's not the same as negative 3 quantity squared, which is where you would square the sign. In this case, the 3 gets squared, but the minus sign does not, because it's not all in parentheses. So make sure you're distinguishing between those two cases. Plus 18 minus 8. So we end up with positive 1. So my vertex is at the point 3, 1. I'm going to plot my vertex, and I'm going to figure out whether my parabola opens up or down. The first term is minus x squared. The leading coefficient is negative 1. That tells me that the parabola opens down because I have a negative leading coefficient. It's just like a reflection about the x-axis, right? Having a minus in front of that x squared does mean that the parabola opens down. So at this point, what I'm going to do is draw in that symmetry line just so that I'll be able to use it when I get to that stage. But I'm only going to draw it in going down because I know that the whole parabola is going to be below the vertex, right? It won't ever go above the vertex. Now from this vertex, I'm going to use that 1, 2, 3, 1, 4, 9 pattern, meaning I'm going to plot the point 1, 1 relative to the vertex, come back to the vertex, and count out the point 2, 4, but again going down, and again relative to the vertex instead of relative to the origin. And come back to the vertex again and plot the point 3, 9, but again going down and again relative to the vertex. That gets me 3 points on the right side of the graph. Now I'll reflect those points to get the points on the left side. Starting with this green point, I can see its reflected point is going to be 1 unit away from that line of symmetry, but on the left. Coming to the magenta point, I can see it is 2 units away, so I'm going to count another 2 units in that direction to get the reflected point. And coming down to this brown point, I can see it is 3 units away, so I'll continue to count 3 units in that direction. I am now ready to connect these points in a parabola. So we do want to make sure that our quadratic function graphs always have the vertex absolutely correct and a few points plotted accurately, but realize that we can get those points without plugging into the function. I didn't have to plug these numbers into f of x over and over and over again in order to get these points. I just use what I know about the graph of y equals x squared and redraw it again really quickly. And just a quick note about graphing parabolas. Sometimes students think they absolutely have to fit all of those points, and there are maybe cases where your vertex is close enough to the edge that maybe the third point will be off the grid. If that happens, that's fine. Don't readjust your scale in order to fit everything. Just plot the points that fit there in that grid. We only readjust the scale if we have to, because maybe the vertex itself doesn't even fit in the grid, or perhaps the vertex is so close to the edge that we really can't get much of a graph at all. So generally assume that if it's reasonable, if you're getting 2 points on each side, that you're fine and that there's no need to change your scale to make everything fit.